client and server on different computer using Python perform the communication between these two entities by using RSA crypto system. So you need to create one client, you need to create one server. So socket programming, you can allow these two computers to communicate with each other. But using the Python language, you have to do this, right? And what is the communication that will happen between the say client and the server? That communication could be RSA, a crypto system, right? That means you have to use RSA encryption and decryption algorithm for that particular communication. And that is your this assignment number 5. Now, first of all, we'll see, this socket programming, the concept, how they come, we know this, right? So, first of all, I will cover this RSA, right? And then how to cover this entire assignment, do this entire assignment, that we'll discuss. First of all, we'll see this RSA algorithm. Let me tell you this RSA, this is a public key cryptography, right? So, that private key and public key cryptography. Private key cryptography is a traditional one where a single key is shared by both sender and receiver, right? So there is a basic problem with this shared key that it may disclose to the third party person and communication will be in danger. And here both parties are equal. That's why it's a symmetric. Public key cryptography. Here two keys you are supposed to use, two key, a public key and the private key. Public key you are using for the encryption, and you are sharing the same you are sharing the private key of the same say user to the for the decryption purpose. It is asymmetric cryptography. Public key cryptography or RSA algorithm is asymmetric key cryptography example, right? Because both the parties sender and receiver are not equal. Here it uses clever application number of theoretic concept to the functions actually, and it complements rather than replaces a private key cryptography. Here in this particular public key cryptography, it is developed to address two key issues like key distribution and say digital signature that we'll cover in the next assignment, that's assignment 6. So key distribution is one of the important issue here. Here in public key cryptography, it uses two keys, a public key which may be known by anybody and can be used to encrypt messages and verify the signature, and a private key known only to the recipient used to decrypt the messages. And it is asymmetric because those who encrypt the messages or verify, for example, signatures, cannot decrypt the messages or create the signature. That's why it's asymmetric cryptography, example of asymmetric cryptography. Now, this public key cryptography, just see this particular example. Here, I hope I'm audible to you. Yes. In public key cryptography, just see the scenario for the encryption. It's a plain text that is the input to the system for the encryption algorithm. For example, RSA algorithm, right? So that RSA we'll see in detail. But let's ask what is the scenario in the public key cryptography. So here you are having box public key rings. For example, the public key say this is Joy's public key, say Mike public key. This is nothing but say example. It's keys that purchase with this particular Bob. So he's having public key of Joy, Mike, Alice, and Ted, right? So this particular encryption algorithm is using Alice public key for the encryption, right? Right. Now, after using this Alice key for the encryption purpose, you will get the ciphertext, and that ciphertext will be transmitted over the network, and it reaches to the receiver end. At the receiver end, here the important point that you are supposed to know that only Alice private key is used to decrypt the message, and then you will get the plain text. That is the scenario here. Alice public key and Alice private key. Here certain characteristics of public key RSA algorithms are like it is computational to find decryption key knowing only algorithm and encryption key. Then it is computationally easy to encrypt decrypt message when the relevant encryption decryption key is known. Either of the two related keys can be used for encryption with other use for the decryption. In public key crypto system, now so for example here you can use double encryptions also, right, for the more authentication purpose. Now source and destination is there. So here first of all encryption with say is public key. You are having some encrypted ciphertext here. The ciphertext is again encrypted with B's public key. It is passed to the destination. In the destination, first of all, it is decrypted with B's private key, and again the same text is decrypted with A's public key, like this. The public key applications like in the encryption decryption, which provides secrecy. In a digital signature, that application is the ISA digital signature that we will see in the next assignment. It provides authentication. Means what? It ensures that the what you can say the that particular point comes message comes from the authenticated user. And third, key exchange. Then security of public key schemes like private key schemes, brute force exhaust search attack is always theoretically possible, right? In most of the cases. But keys used are too large here, greater than 5 and 2 bits also. Right? Then security relies on a large enough difference in difficulty between easy and hard problems. Then here generally large prime numbers are used for you can say providing the security. Now we'll move to the RSA algorithm. What is the RSA algorithm? This RSA is algorithm the most popular and proven asymmetric key cryptographic algorithm. Now, before we discuss this RSA algorithm, let's have a quick overview of prime number, concept of prime numbers, as they form the basis for the RSA algorithm. Now, what is prime number? A prime number is the one that is divisible only by 1 and itself, right? For instance, 3 is a prime number because it can be divided only by 1 or 3. However, you can say 4 is not a prime number or 6 is not a prime number because other than 1 and 4, it can also be divided by 2. Right. So likewise, 5, 7, 11, 13, 17, these are our prime numbers. Right. Now here a quick observation you can have with respect to this particular prime number concept. Prime numbers above 2 must be an odd number because all even numbers are divisible by 2, right? And therefore all even numbers from 4 onwards are non-prime. Always remember this. So whenever you're talking about this particular RSA algorithm, this RSA name is given to the, you can say that this scientist Ron Rivest, Adi Shamir, and Len Edelman. So R, S, and A. So they have developed this algorithm, Rivest, Shamir, and Edelman. So important point, it is a block cipher. Concept of stream cipher and block cipher we have seen. Encryption done in a blocks in multiples of 8. So it is a block cipher which converts plain text into ciphertext and vice versa at the receiver side. Now just consider this particular algorithm. What is that algorithm? Select two prime numbers P and Q, where P is not equal to Q. Calculate N is equal to P multiplied by Q. That N you have to calculate. Calculate say 5 of N so that P minus 1 into Q minus 1. You will add 5 of N. Select E, that is encryption key, such that is relatively prime to 5 of N. Is relatively prime to 5 of N. Now, that what is relative prime that we'll see. So E comma 5 of N is equal to 1 and it should come 1 and 1 is less than this encryption key less than 5 of N. Always remember this. Then calculate decryption key to the power minus 1 mod 5 of N, or you can calculate using this ed in d equal to 1 mod 5 of N. So you'll get the value of d because you know 5 of N, you know E, right? So you can get the decryption key. So you now having public key pairs like public keys E comma N and private keys D comma N. N is this one. Now you need to find out the ciphertext using the formula C is equal to P to the power E, that is, and mod N. C is equal to P to the power N, E power E mod N, where P less than N. And C is equal to ciphertext, where P is equal to plaintext and E is encryption key and N is the block size. Right? That N is what nothing but the block size that you have calculated here. Now P is equal to C. Now you need to again get back the plaintext, that is description or decryption. So how to do this? P is equal to C to the power D, the D is decryption key, mod N. Now plaintext P can be obtained using the given formula where D is equal to the decryption key. right? So we'll step by step see the what you can say execution of this particular uh, RS algorithm. Now step 1, select two prime numbers P and Q where P is not equal to Q. So here say we are selecting P13 and Q11. So P is not equal to Q. Step 2, calculate the block size N is equal to P into Q. So N is equal to P into Q, that is 13 into 11, that is 143. So N is equal to 143, block size is coming. Then calculate phi of N such that it is P minus 1 into Q minus 1. So 13 minus 1 into 12 minus 1, that's 12 into 10, 120. So phi of N is coming 120. Now you need to select E, encryption key, so that the GSD of that encryption key with this particular phi of N should come 1. Now here, so GSD of this E, phi of N is equal to 1. And E is the this E is the public key for the encryption that is required. So E is the public key. So you have to select. Here we are selecting E 13. That is select E such that E is relatively prime to phi of N. So we are selecting E 13, which is relatively prime to phi of N. That is 120. That means here GSD of 13, 120, that should come 1, or E, phi of N is equal to 1, like this. That condition should satisfy, and also this one. So here we are selecting encryption key is 13. That is also public key for the encryption. Step 5, calculate decryption key D is equal to ED is equal to 1 mod phi of N. So finding D. So E into D mod phi of N, right? So equal to 1. So 13 into D mod 120 is equal to 1. Now here you need to how to find out this D of E is equal to 1 mod phi of N, this one. So here D is equal to, we have simplified this, phi of N multiplied by I plus 1 divided by E, that is encryption key. So we'll start with I is equal to 1. We are substituting the value of I, 120 plus 1 divided by 13, that's it's coming 9.30. Then we are changing I value from 1 to 2, it is coming 18.43. Then it's coming 27.76 for I is equal to 3. When I will become 4, the value is 37 and it's a complete one, that is it's integer. Once you get the integer value for D, that will be your private key for the decryption. So here D is the private key, that's coming 37, right? So you have to continue this process of I1 to 1 onwards till you get the integer value for the D. Step 6, public key is now EN and private key is DN. What is E13? D, I think 37. So your public key is 13, 143, that is block size, and 37 is the decryption key, block size 143. Now go for the encryption. So encryption is equal to, for example, my plain text is P is equal to 13, which is less than the block size. So C is equal to P to the power E mod N is equal to 13 to the power 30 mod 143. It's coming 52. You can solve. So the ciphertext is coming 52. Decryption is equal to plain text is equal to C to the power decryption key mod N, that is 52 to the power 37, that is the decryption key mod 143 is coming 13, that is the original. So P is 13. So in this particular fashion, that RSA algorithm will work. Now, whenever more things about this particular RSA, if you want to know, it is a asymmetric cryptography algorithm. Asymmetric means that there are two different keys. This is also called as the public key cryptography because one of the keys can be given to anyone. So public keys can be given to anyone. Now here, two main components are there in this particular case. Key scope is reverse. Public key of receiver is used to encrypt data, and private key of receiver is used to decrypt the data. Always remember this. Key exchange is not necessary in this particular case. That's why it's somehow safer. So two main components: key generation and the encryption and decryption function. So key generation is the one important point. So there are two large prime numbers. You are taking P and Q. Already I explained the algorithm, entire algorithm. You need to compute the blocks as N is equal to P into Q, right? And phi of N, or here Z is equal to P minus 1, Q minus 1. Now you have to choose a number encryption key where 1 less than E less than P minus 1 or Q minus 1, that is phi of N. Now a number D is selected so that ED mod Z is equal to 1. that means this one, and calculated as d is equal to the power minus 1 what p minus 1 q minus 1. So substituting the i's values accordingly, we have seen that public keys any and private key ending, same algorithm step. And in the encryption decryption process, c is equal to this particular plain text to the power encryption key module, and again plain text you are obtaining m is equal to ciphertext to the power d module. Same steps in some different fashion. I'm explaining to you. You take the example encryption, say p and q 7 and 13. So your n is coming 91. Now here you select e to be 5 since it satisfies this condition, right? 1 less than e less than p minus 1 q minus 1, and value of d is coming 29 after solving this particular equation. So public key is 91, 5 and private key is 91, 29, or you can like say 5, 91 or 21, 9, 92. It's up to you. Take the less plain text is 10, so your ciphertext is coming 10, 82, and again using decryption it is coming 10. What are the advantages of this RSA? There is no need of sharing secret keys. Proof of owner's authenticity is there. Faster encryption than this DSA, and the data can't be modified in transit. That is one of the advantages of this RSA. Right. Now come to our actual assignment here. Now RSA is there. What is RSA and how that algorithm I have to use? I explained. Now you need to implement a client and server on different computers using Python. Now let's say in Python, first of all you need to have some client and the server. So here you have to first of all create a program server.py. First of all, establish a communication between client and the server, and then you have to what you have to do. You have to, whenever the server responds to the client, you need to what you can say encrypt that data and send. So first of all, how to establish a connection in the using Python. So here you need to create the socket. Say S is equal to socket dot socket. So socket dot af underscore init and socket dot sock underscore stream. That is for the TCP connection. If you remember this already in the assignment number 3, I explained these connections. Then s dot bind is equal to socket dot get host name. So it will be going to give the get host name, so IP address of that particular. If you are working same machine, it will give the local host name. Otherwise, it will give the name of the different machine, IP address of different machine, port name you have to use. Here, if you write here s dot listen, now socket server will listening. So we say allowing maximum 5 connections. So s dot listen 5 up to 5 connection. What you have to do while it's true, client socket comma address equal to s dot accept. It accepts server accept the connection from the client, and it prints the client's IP address. That means connection with that particular client with this IP address is established. Then you can enter any value at the server side. Say val input enter union, for example. So it will take that input. Now here you can send that particular value to the client and just check whether the connection is established. On the client.py, the other side, client.py, what you have to do, import socket. So on the client side, again, you have to create a socket as socket.socket, this standard format. Then s.connect socket get hostname, right? So that particular hostname you have to connect it to the server with the port address 1234. Then you are typing certain message, you just dot receive, you are getting some message from says first from server, right? Has.receive. So print that particular message and close. So whenever you execute this, first of all server, you will get a connection from this particular machine has been established. You are entering this value is 50, and then the client side that 15 value will be displayed, right? So in this particular machine, this particular connection will be established. Now, when you are actually here typing enter value 15 on the server, what you can do, I will suggest to you on the server side here, after entering the value here, right, do one thing, that value is nothing but your plain text value, right? Then you have to generate the keys, generate public keys and private keys. I tell you, you need to generate public keys and private keys, and you have to send that particular we can say that key to the client along with the this particular message, and that particular value will be used for the decryption purpose, right, at the client side, and the original message will be get back. So here you have to use the RSA algo, right? Here you can use the RSA algorithm, their code, and then you will get the resultant hypertext. That hypertext you have to pass to the client, and along with the, you can say, private key also, and then you can decrypt the same thing using private key. Are you getting my point? So in this particular fashion, you are supposed to do this, right? So this is what the main thing behind this assignment. So using Python, you have to do this. So just say you have to install Python and PyCharm on your machine. See, this Python you can install Python 3.10.2 AMD64 and PyCharm, this one. And you can open the PyCharm also. Now, for example, suppose I am creating the suppose now here already you can say use file, right? File, then you can say new project, and that project will be created to you, and you can create. So the main file will become, you can rename it as client, and you can create one more Python file, server.py, right? So here client and here's the server. These two files are there, client and server. Now see, this code I am copying to the server, right? Here as it is, you just see server. I'm just trying to actually इसको थोड़ा मैं उसे कर रहा था, but it's okay. If I can rename this as, will create rename. Client. So we'll just say client. I will first of all copy the code of server here. Client client and server. So first of all, I will execute this server, and then I will execute this client. Now here you just see server. It is saying connection from 19 to 100.70 is established. That means connection between these two are established. And